intelligence and pattern recognition, starting from machine learning. And to give an introduction about them, so hailing from Pollachi, Dr. Arun Kumar sir, he has completed BE in CSC, Computer Science and Engineering, at Dr. Mahalingam College of Engineering and Technology, Pollachi, in June 2004. Then completed his MTech in CSC at VIT, Vellore Institute of Technology, in June 2006, and he has his doctorate, completing PhD in Information and Communication Engineering at Anna University, Chennai, in the year 2019. Then he started his career actually from Wipro Technologies, Bangalore. Then, out of his own interest, he switched over to the teaching field, and he's working currently in Amrita University in the Department of Computer Science and Engineering. He's responsible for starting the teaching profession, and he has started the chapter IET, Institution of Electronics and Telecommunication Engineering Students Forum, in all engineering colleges and polytechnics in Tamil Nadu under the jurisdiction of IET Coimbatore Center, expanding its wings to more than 12 districts in Tamil Nadu. And then he has inaugurated students forums and delivered technical and non-technical lectures in more than 50 engineering colleges in Tamil Nadu, including premier institutions like Vellore Institute of Technology, PSG College of Technology, followed by so many colleges, and including now our Info Institute of Engineering also. And then he has assisted the Amrita University in conducting a one-day tutorial in the area of network security in association with Symantec Corporation at IIT Madras during May 2010. And then assisting the project works. So Amrita has won third prize in the IEEE region under the website design competition under his leadership. He was also appointed as organizing secretary for the International Conference on Distributing Computing and Networking in 2014, which is one of the top 10 conferences in the world in the area of distributed computing, hosted at Amrita University. He has published more than 30 papers in leading national and international conferences and journals. And I suppose he's an apt person today to give us a proper guidance and deliver his speech on artificial intelligence and pattern recognition. So now I'm handing over to Sir. Sir, please.
Yeah, thank you, madam. So we will start the session. I will just share the screen. And anyway, this lecture is being recorded. So I will just share the video also after the program. So is it visible, madam? The screen?
Yes, sir, it's visible, sir.
Okay, madam. Okay. So we will start the session. So we will start the session with an introduction to machine learning. So if you look at this screen, where this screen most of the time you are familiar with. So what do you think is common in all these things? You know, for example, when you buy a product on Amazon, like a mobile phone, you search for buying a mobile phone on Amazon. Then you add the item to the cart after you found an apt mobile phone. After that, what happens? Most of the time, it will show you frequently bought together. If in case you are probably buying a mobile phone, it will say frequently bought together, maybe a case or tempered glass and so on. So it will say mobile phone plus case plus tempered glass. This is the amount and so on, right? So the same way, if you see here, the right side, there are two things. One, For example, identification of legitimate and spam emails. So most of you are commonly using the Gmail. So in the Gmail left side panel, you can see inbox, sent mail, trash, and so on. So there you would find a specific folder called spam with some number of messages automatically populated into the spam folder. So how do you think this works? How the computer will probably identify a particular mail.
Sir, please, sir. I suppose you are not audible. Sir?
Yeah, I think there was some connection glitch. One minute. I am just sharing the screen again. Just hold on.
Okay, sir. Now before that, students, all of you, if you can show your faces, then with sir also we can take a snap. On students, please switch on your camera, show your faces. We shall take a snap, including sir.
Okay, 1 minute. I think in the settings, I just disabled camera. 1 minute. I am just enabling the camera for them. 1 minute.
Okay, sir. Okay, sir.
1 minute. 1 minute. Yeah, now I have enabled the camera for everybody. So
Okay, sir.
maybe others can quickly switch it on. Switch on the cameras. Yeah. Others also, you can please switch on now. Then later you can. And I think anyway it is recorded. I will send you the attendance list also, madam. I will download and send the attendance list. Yeah. I think quickly you can take, madam, one screenshot so that we can start the session. Is it fine, madam? Enough?
Yes, sir. I suppose it's okay now, sir.
Yeah, I think it is enough, madam. Yeah, no problem.
Yes, sir. Okay, sir.
Yeah, I think it is okay. So I will download the attendance list also and share with you, madam. No problem.
Okay, sir. Okay, sir. Thank you, sir.
Okay, thank you.
Yes, sir.
Yeah. So what we were seeing is, whenever you look at the Gmail account and so on, so you find something like the spam email, right? So when an email is sent from someone to you, automatically Gmail will be able to classify whether it is a legitimate mail or spam mail. If Gmail considers it to be a spam, it will automatically put in a folder called spam. So how does this work? Machine learning replicates activities that require human cognition. See, these are some other examples that you could obviously see. For example, some of these things which you use on a day-to-day basis, for example, Netflix, that you use for watching movies or series, YouTube, Facebook. So every time you use Facebook, Facebook obviously shows you some suggestions like, friend requests, suggested friends list, and so on and so forth. So when you look at the last application, which is probably the face recognition system, the facial recognition system is nowadays most widely used in almost many of the industrial applications, even in educational institutions. This face recognition is very much commonly used. The most common use of face recognition system is to mark the attendance. For example, you can use it to mark the attendance in a classroom, or we can use this face recognition system to mark attendance for the inmates residing in the hostels, etc. Right? So when you look at all of these examples, all these examples typically show how your machine or a computer is able to learn and then use the system more effectively. That is what we want to drive in here. Okay. So what is machine learning? So let us learn machine learning with Patty and her brother. Okay. So a brother and a sister are having a very short conversation. So what is machine learning? Machine learning says a field of study that gives computers the ability to learn without being explicitly programmed. Look at the definition, very important. The field of study that gives computers the ability to learn. That is the first part of the definition, where a computer is given the ability to learn. The second part of the definition is also important, without being explicitly programmed. This is an older informal definition, okay, for machine learning. So I will tell you what is machine learning very simply. This is a simple conversation between a brother and a sister. So Parry says, well, that is the buzzword everyone is talking about, machine learning. Can you let me know what it is all about, machine learning? So the brother simply replies, machine learning is learning from data. Okay. Okay. So she asks, learning from data? I don't get it. you are talking to a layman, so please talk in simpler terms. So the brother starts explaining his sister as follows. Imagine you are going to bowling, snow bowling, let us say, to Brookfields, okay? And it is your first day. So what do you think? How will you perform? I think very bad, because I remember the very first time I bowled, I throw all the balls in the gutter. And what about today? Well, today I think I can easily drop at least 7 in a shot. But what this has to do with machine learning? Let me explain. But how did you improve your game? Well, it is simple. I practiced, and with time I got experience. I got to know that I need to adjust the angle at which I am throwing the ball. Also, I need to pick a lighter ball for better accuracy. So what is the underlying concept here? Well, so over time, you got experience by tweaking some parameters and your game improved, right? This is what is called machine learning, right? This is what is called machine learning. So what is machine learning? Learning is any process by which a system improves performance from experience. Okay, so this is what is learning. Learning is a process in which a system, not only a system, human also, okay, should improve his or her performance from experience. So machine learning is concerned with computer programs that automatically improve their performance through experience. So the very first time you write an examination, you may perform very badly. After that, you understood the system, you know how the system works, how the question paper is set, what is the pattern of the question paper, and so on. So successive examinations, you may be able to perform better than the first iteration, right? So that is what is called learning. So learning is a process in which a system will keep improving its performance from experience. So learning by machines, machines are nothing but computers. Learning is nothing but history. So Tom Michel says a computer program is said to learn from an experience E. Okay, just for our simple understanding, I am marking experience as E. Okay, with respect to a set of tasks, I mark it as T. The performance measure as P. So if its performance at tasks in T as measured by P improves with experience E, okay? Very simple, 3 parameters. E is the experience, T is the number of tasks that you're going to give, and through which P, the performance measure, needs to improve, okay? This is a very simple logic. So machine learning is concerned with computer programs that automatically improves its performance through experience. This is very important. So as you learn, as days progress only, your experience you will gain, and through that your learning will improve. So suppose your email program watches which emails you do or do not mark as spam, and based on that learns how to improve its filter spam. So what do you think is the task T in this scenario? There are 4 options given. So the task T needs to be identified from the scenario. The scenario is very simple. Suppose your email program watches which emails you do or do not mark as spam. And this will help to improve its filter. What is the task T in this scenario? So there are 4 options. Obviously, the answer would be classifying emails as spam or not spam, because that is the problem I would like to probably address. So any kind of an email that comes into your system, I would need to mark it as spam or not spam, right? That is my key objective or goal. So that is what we are going to do. Okay. So Classifying emails as spam or not spam is the task T. Watching you labels email as spam or not spam is called E, is otherwise called experience. And as experience is gained, the number of emails correctly classified as spam or not spam is denoted by the letter P. P is something called the performance measure, which is our ultimate goal, is to improve the performance measure. So my performance measure is basically after gaining some experience E and doing a set of tasks T, my performance measure P needs to improve, where I would be looking at how many emails out of say 100 are going to be correctly classified as spam or not spam. Okay, this is a very, very simple example I have given you. The same things hold good for some of the other applications, which we would quickly go through. For example, if you take a handwriting recognition problem, the task T is recognition and classification of handwritten words within images. The performance P is the percentage of words that are going to be correctly classified. And experience E is a data set of handwritten words with given set of classifications. The next typical example is a robot-driven learning problem. Let T be the driving on highways using vision sensors. E is the sequence of images and steering commands recorded while observing a human driver. And the performance measure P is going to be the average distance traveled before an error happens. And error obviously here would be in terms of, say, for example, an accident and so on. A chess learning problem is another typical example for a machine learning problem where the task T is to play the chess. Experience E is playing practice games against itself so that it trains itself, and the performance measure P will be the percentage of games won against its opponents. Okay, fine. So this is what is a typical example of machine learning. Well, okay, but how do machines experience? They are not humans, right? This is a very typical problem. How do machines experience? See, humans, you can obviously know. For example, if you take a very small kid under the age of 5 or so, if you probably tell the kid, which is less than 5 years old, that if you probably take a small matchbox and then light the stick, you will get your fingers burnt. That kid might not listen to you because he doesn't know anything. So probably sometimes when you are not around, it may take a matchstick, light it and see. And if in case, for example, if it gets its fingers burnt, then it has learned its lesson the hard way, right? So that is called experience. So when you tell somebody for the very first time, so they may listen to you or they may not listen to you. But through experience, when they have learned it the hard way, then they know what to do and what not to do, right? So that is the biggest problem with the younger generation now. So if for example, it is humans who have senses, it is very obvious, right? Just hold on 1 minute. So what sense, obviously, but how do machines experience? Yes. So if you talk of machines, computers, for example, is the basis for a machine to experience? It is nothing but data. So experience for a computer machine will obviously come from historical data, right? Historical data. So this is a very typical example that you could in many of the applications used nowadays. So one common application which everybody is aware of that comes in the news every day is called the weather forecasting system. So every day in the news, they have a very small part that basically how the weather is going to be for the next day or for the next couple of days, for the next week and so on, right? So sometimes they will say, it is going to be cloudy. Sometimes they will say it is going to be heavy rains for the next 3 days, or it is going to be very hot for the next 4 days and so on and so forth. So how is that prediction basically done? Yes, that prediction is basically done by using what is called historical data. Historical data is nothing but, for example, I have weather data till yesterday captured from satellites, which I feed it into a supercomputer. The supercomputer does what are called number crunching algorithms. The supercomputer does a lot of computations with those data and then arrives at what is called the prediction. What is prediction? The prediction will say what is going to be the weather condition for the next 1 week. So now this is one thing of machine learning. Okay. So what do you mean by learn? Machines don't have brain, right? So how does machines learn? Exactly. Yes, machines do not have brains. Humans have brains. They will be able to learn it slowly or quickly. But as machines do not have brains, how will machines learn? Yes. How does it learn? This is where mathematics comes into picture. Machines learn by using some complex mathematical concepts, and for them, every data is going to be in the form of zeros and ones. This is important. You know why? Why data is in the form of zeros and ones? Because yes, we talk of a computer can be as powerful as you think. It can do a lot of computations, but still at any point of time, it cannot surpass human intelligence. So you talk of machine learning. Okay, the computer can learn on its own using historical data, using complex mathematical formulas. Okay, fine. But still, computers lack what is called human intelligence. Computers will not be able to think on their own. So we will see why as we progress today. Computers can only learn from zeros and ones because computers can only understand binary language. So we don't want to code the logic for the program. Okay. So instead we want the machine to figure out the logic from the data on its own. And that is what is called machine learning. Machine learning says, I will not code the logic for my program. I want the machine to figure out the logic if I could probably supply the data. Okay. That is our key objective of machine learning. So what do you mean by that? We do not need to code the logic. So we do not have to write hard code rules as we write in any other programming language like C, C++, Java, and so on. I will tell you what is machine learning with another simple example. Okay, suppose I have a very small set of data about a payroll of employees in a company. Okay. So it has experience in one column and salary in another column. Please observe the data for a few seconds. Experience in terms of number of years and salary in terms of rupees. So do you find any correlation between experience and salary? Take some time to look at the data. What do you infer? It is very clear from the table that when experience is less than or equal to 10 years, the person is getting salary that is into 1.5 times the experience. And when the number of years of experience increases above 10, what obviously happens, this factor increases to 2. So 12 into 2, 24 lakhs, 14 into 2, 28 lakhs, and so on. So how will you code this? If you need to predict the salary for a person with 8 years and 16 years of experience, how to code? If experience less than or equal to 10, salary equal to experience into 1.5 into 1 lakh. Else if experience greater than 10, salary equal to experience into 2 into 1 lakh. So we don't do this here, right? We don't write if else in a machine learning algorithm. We don't need to supply the logic. It is up to the machine to find out, figure out the logic given the set of data. That is the beauty of machine learning. I do not want to write large programs with all less nested if else if loops. Okay. So, but this was pretty easy, right? Even I could figure out the relation in the data. Well, this is easier if the number of data, the size of the data is small. What will you do when the scale of the problem increases? Now, can you find the relation between experience, job level, rare skills, and salary? It is a kind of difficult, right? This is where machines come into picture. The factor of 1.2 or 2, which we just calculated in the previous example, is what is called the weight. Okay, this is another new term I'm introducing you to machine learning. This is what is called the weight. Okay, fine. The columns in the yellow that you see, for example, experience, job level, rare skills, and so on, are called the features. The column that you see in red, marked in red, called salary in rupees, is called the label. So we calculate the weight of the features that contribute in deciding what is called the label. Very simple explanation for machine learning. Okay, so use the features, calculate the weights of the features, and that will contribute to the last column. And that is what is called the label for your entire data set. Okay. But you only said we do not code the algorithm. The focus is on the data. So actually data plus your algorithm will obviously provide what are called insights. Algorithms are already developed for us. We need to know which algorithm to use when. That is what is the basic idea of machine learning. So the machine learning very clearly says there are certain algorithms that are predefined and optimized. It is up to the user, statistician, to use those available optimized algorithms for your supplied data and then derive meaningful insights from your data that you give using the existing algorithms. And that is what is called machine learning, ML. The next question is why machine learning? Why do you think machine learning is important? So for example, a very simple question. How many hours do you use, say, Facebook or Instagram or Snapchat daily? So say, for example, you use it for about an hour. Do you know Facebook is using machine learning to tag your friends in your uploaded picture? Do you know Facebook shows custom video recommendations based on your internet history? Oh, so is this the reason not all news feeds are the same? Yes, exactly. Facebook knows your likes and dislikes based on historical data and machine learning. So this is the key thing everybody should understand. Whenever you search anything on the internet using your laptop, your desktop, or your mobile phone, you are continuously monitored. So whatever the keywords that you supply in your Google search is fully monitored. The next time you use any of your YouTube or any of your social media applications like Facebook or Instagram, obviously you will get related fields. Whatever you have searched, according to that, you will get the news feed. Okay, so this nobody can stop, which means you are going to be continuously monitored. Obviously, there is another major concern with this. where we always talk of lack of privacy. Okay. Another simple example I would want to give you so that you are aware of what you do on your mobile phone. So for example, when you go install an application on your mobile phone from your Play Store or an iOS store or whatever, when you start installing the application will keep asking for permissions. So nowadays, typically there are three different kinds of applications, permissions that are being asked if you have seen. The first kind is, it will say not now. For example, if you click not now, you will not be able to install the application. The second kind of recommendation that you normally get is only this time, or whenever the app opens, you can give it. That is second type. Third variety is the most dangerous one. Whenever you want to probably give permissions, the third variety is the most dangerous. You give all times, every time. Okay. So because we are very lazy, we just click every time. So what happens once you click every time, whenever you are probably installing an application on your mobile, automatically you have compromised all your data, whatever is existing, all your mobile phone, including the contacts list that automatically goes into the application. So now anybody who is an admin for that application will be able to tamper with your contact information. He may be able to sell your contact information to any kind of a third party. So that is where I am telling you the privacy and security has already been compromised. So you have to be very, very careful whenever you install any kind of an application on your mobile. So which mailbox you are using? For example, Gmail. Okay. Do you know how Gmail knows that a particular mail has to go to priority, social, promotion, or a spam box? Again, obviously, this Gmail uses what is called machine learning. So it has millions of emails tagged by users in a particular category. So by the use of machine learning, the Gmail will observe the patterns and automatically classify an email into any of the fields. So even the keyboard that you are using today uses machine learning to predict your next word. This, I think everybody is very much familiar. You have autocorrect in WhatsApp itself, and you always have some kind of applications where when you compose an email, as you type an email, it will automatically suggest the next word and you can easily go just select it. How does it happen? These are all happening only because of what is called machine learning, otherwise in short called ML. So are we providing data to Google every time we type? Yes, that is what I'm telling you already. You have already compromised on your privacy. And Google is obviously doing some kind of amazing things with that. And one such example was in the Google I/O 2018, what they have done. So Google incorporated what is called Morse code into Google Keyboard. So it knows the conversions now due to the presence of the large translated data. So which website, for example, do you use for shopping? For example, let us say Amazon. Yes, it is amazing. But amazing thing is the Amazon's recommendations. So very like we have video recommendations, we have product recommendations using machine learning. You have something called an Amazon's recommendations engine. You know, it has fetched about $35 billion for Amazon as revenue because of this recommendation engine. So whenever you go buy a product on Amazon, what Amazon basically does is shows a set of featured recommendations. It will say bought together plus with some offers. And because of this, Amazon has already generated a revenue of more than $35 billion. You can calculate how much it is going to be in Indian rupees. So where are we watching the videos? Everybody knows YouTube, of course. And again, are you giving me an example of recommendations in YouTube? No, this time it is a bit difficult. You know how much of content in hours is getting uploaded on YouTube in a minute? Can you make a wild guess? Yes. It is almost close to 500 hours. So YouTube do not have that much staff to review each of the content for nudity, violence, and copyright, right? So what it does, when the scale of the problem increases and whenever more and more data comes into the system, what does it do? It turns out machines are only our last hope, right? And that is where we need what is called the two-letter buzzword that you hear every day, otherwise called artificial intelligence, right? Okay. So, but all these companies are the big four. My company will never use this technology. No, machine learning is not just a buzzword. This is going to be an amazing technology that can see such things which are not visible to the naked eye. So when you look at 2020, the estimated amount of data created on the internet in a minute. For example, Netflix, there are about 4 lakh hours of video streamed by users in a minute. 6,659 packages are shipped every minute from Amazon. There are 2 lakh plus people who are using Zoom in a meeting. There are 500 hours of video uploaded by users, 3,47,000 stories on Instagram, 52,000 users are connected on Teams, 41 million messages are shared on WhatsApp. And please note, these are all estimated amount of data created on the internet in 1 minute. Yeah, not even hour, it is in a minute. So this is the amount of data. This is the flood of available data. Increasing computational power, growing progress in the available algorithms, and increasing support from industries. All this make this happen. So when you talk of traditional programming versus machine learning, when you talk of traditional programming, you have a computer, you supply data, you give a program, the computer will give you the output, right? That is what we have been doing. So when I ask you to write a very simple program that finds the average of n given numbers, you give the data as n given numbers, you have written a logic for the program, you feed it into a computer, you write the program using any programming language like C, C++, Java, and so on, and then you get some output. Okay. Then what is machine learning? Machine learning is interesting. You give the data as input. In addition to that, you give the output to the computer, and the computer needs to give you the program as the output. Okay, so the data is nothing but knowledge. And this machine learning, otherwise called ML, basically deals with what is called uncertainty, right? That is what is a typical example I told you. When you type something on your keyboard, as you type it, it will obviously show what is the next word probably you might type, and it will show you suggestions. Yeah. So the machine learning will be able to deal with what is called uncertainty, but your traditional programming will not be able to deal with any kind of uncertainty. Your traditional programming can deal with only definitive cases. So a machine can forecast. A machine cannot create something new. That is what is human intelligence. A machine can memorize and do the same things repeatedly, monotonously. A machine cannot get smart really fast. A machine can reproduce. A machine cannot go beyond its task. A machine can choose the best item. A machine cannot kill all humans. This is very, very important. So at no point of time, a machine can replace humans. A machine is only a complement to human. A machine can never replace a human being. No. So what are the components of machine learning? We have data, we have features, we have algorithms. All these three overlap. And when I take the common aspects of the data, features, and the algorithms, I get what is called ML, machine learning. For example, if you take data and combine it with the features, I get what is called data science, which everybody is famous, right? Everybody knows it. When I take data and combine with algorithms, I get what is called data mining. When I take an algorithm or a program and combine with the features, then I get what is called classical programming. Whenever there is an overlap of data science, data mining, classical programming combined with data, features, and algorithms, I get what is called ML, otherwise called machine learning. So what is AI? AI is the study of how to train the computers so that computers can do things which at present humans can do better. So ML, machine learning, is an application of artificial intelligence that provides the system the ability to automatically learn and improve from E. E is what we have learned earlier. If you remember, E is called experience. So when you see some circles here, the outermost circle is called artificial intelligence, programs with ability to learn and reason like humans. Inside it, I have machine learning algorithms with the ability to learn without being explicitly programmed. That is the beauty of machine learning. And there is an inner core to it called deep learning. Deep learning is a subset of machine learning in which I use what are called ANN, otherwise called artificial neural networks, that will adapt and learn from vast amount of data. So what do you think is that learning versus intelligence talk of? Will neural networks replace machine learning? This is so funny, like how you asked, will wheels replace cars, right? No. A car will obviously require a wheel as well as a part. That is what is machine learning and neural networks. So artificial intelligence is the name of a whole knowledge field, similar to what you call it as a biology or chemistry. Machine learning, ML, is a part of AI. Neural networks is a part of machine learning type. And deep learning is the modern method of building, training, and using a neural network. This is what I want you to understand. The typical difference between an AI, ML, neural network, and DL. DL is otherwise called deep learning. So when you talk of machine learning comes in different flavors. The first flavor is called classical ML. The second flavor is called reinforcement learning. The third flavor is called an ensemble. And the fourth flavor is called in short NN and DL, neural networks and deep learning. The first flavor talks of classical ML, which uses simple data with a clear feature. Okay, no ambiguity. Number two is called reinforcement learning. Reinforcement learning beauty is no data, but we have an environment to interact, which uses what is called continuous feedback to learn. The third flavor is called an ensemble. When the quality is a real problem, you need to depend on what is called an ensemble. Ensemble is equivalent to what is called a hybrid. Hybrid is nothing great. Hybrid is something like a masala where you take two or more methods, take the good things out of it, and then combine. That is called an ensemble. The fourth flavor is called NNDL, neural networks and deep learning. Whenever you have complicated data, unclear features, ambiguous features, you want to believe in a miracle, then obviously you can choose neural networks and deep learning. When we talk of a classical machine learning is basically divided into two categories, supervised and unsupervised. So whenever the data is pre-categorized or numerical in nature, we use what is called supervised machine learning. Whenever the data is not labeled in any way, we use what is called an unsupervised algorithm. So whenever you want to do any kind of a classification, for example, that talks of classification of an email as spam or not spam, that talks of classification of a disease, whether a person has a disease or not, and so on. That comes under the classification problem, which is called supervised. Whenever you talk of dividing a particular thing based on the length and so on, then you talk of regression problem, predict a number. The second category is called an unsupervised algorithm in machine learning. So for example, when you want to split up similar clothing into stacks, it's called clustering, right? Clustering is grouping for similar features. Whenever you want to do what is called a dimensionality reduction, then you need to use what is called an unsupervised algorithm. So dimensionality reduction is another typical application that you should always remember. What is dimensionality reduction? Very important. Whenever you work on your final year project also, dimensionality reduction is very important. So dimensionality reduction typically says whenever there are a number of features. So I will give you a typical example. Okay. Let us take a human gene example. Okay. So the simple problem is I want to classify whether a human has cancer or not. This is a typical problem. In order to do this classification, whether a human has a cancer or not, which is a dreaded disease, as you know, what you can do is probably take a DNA from a human sample, blood. The DNA will be converted to mRNA, otherwise called messenger RNA. That messenger RNA will be synthesized to form proteins. From the protein structure, I derive what are called the gene features. As you know, a human being will have thousands and thousands of gene features. When you extract all these features and populate it into an Excel sheet, what you will find is, you will have thousands and thousands of features. The main problem is here, whenever you want to identify whether a person has cancer or not, not all genes contribute to the form, cancer disease. Only a very few genes probably will contribute to cause of cancer. Now, my objective is to find out which are the few genes that will probably contribute to the form of forming a cancer cell. Now, what you need to do, we cannot work with thousands of genes. Now, I choose a simple unsupervised technique called dimensionality reduction. What is dimensionality reduction? Dimensionality reduction will basically try to eliminate the features that are not critical. Okay, now another question is, how do you identify whether a feature is important or not important? Let us take one simple dimensionality reduction technique like information gain, IG in short. Information gain is a dimensionality reduction technique that works on the concept of Bayes' theorem. Everybody should be aware of what is Bayes' theorem. Bayes' theorem works on what is called conditional probability. People write Bayes' theorem as P of A by B. That is how I read. But it is actually P of A given B. So now when you do dimensionality reduction using information gain, IG, information gain algorithm, dimensionality reduction works on the concept of what is called entropy. You will calculate entropy. Whenever the entropy value is 0, I will eliminate that feature because that feature does not contribute to the prediction of the disease. So whenever the entropy is 0, I try to remove that feature because that feature does not contribute or does not add any information to the available data to predict whether a human being has cancer or not. So this is one simple dimensionality reduction technique. So whenever you use dimensionality reduction technique, you will be able to extract the key features from your data set, and then you will be able to do a better analysis. Okay, now, so I will show you a very simple, very short video now, and then I will tell you what it basically typically means. So you might have watched one amazing technology that is already in the US. It's called the Amazon Go. Yeah, it's a new kind of store feature, the world's most advanced shopping technology. No lines, no checkout, just grab and go. That basically uses the concept of machine learning clubbed with artificial intelligence and deep learning to probably make shopping a seamless experience. Okay, fine. Now, coming to the ML terminologies, which you should know. The first terminology is the algorithm. What is an algorithm? An algorithm is a method, a function, or a series of instructions used to generate a machine learning model. Next, what is an attribute? An attribute is a quality describing an observation. And number three, dimension, how much feature you have in your data. The next one is called the training set, the test set, and the validation set, which you should be aware of. What is a training set? Training set is a set of observations used to generate machine learning models. What is a test set? A test set is a set of observations used at the end of the model training and validation. Okay. Validation set is a set of observations used during model training to provide feedback. Now, based on this, I will tell you how we can do. For example, let us take a sample data of 100 patients who come to a hospital to probably check if they have been affected by cancer or not. Okay, very simple example. Let us say you walk into a hospital with some kind of symptoms, and the doctor basically has some kind of a doubt whether you might be affected by cancer or not. So the doctor may order a set of tests, including scans, blood tests, and so on. Yeah. So let us say like that you have about 100 patients who walk into a hospital and do a cancer screening test. Out of that, maybe about 5% of the people, 5 patients might have cancer. The rest 95 are all going to be normal patients. Now, when you use this data in machine learning, where there are only 5 patients with the disease and 95 patients are normal and only 5 patients with cancer, you will not be able to train and test this data set The obvious reason is the number of normal patients is much more than the number of patients who have been affected by cancer. If you use this data set for training and testing your system, obviously you will get very good result. Your accuracy will be almost near to 100. So don't be very happy about it because your data is not balanced. You are working with what is called an imbalanced data. So whenever you want your results to be more accurate, please remember that you always need to work with balanced data. So what is a balanced data? If, for example, there are 100 patient data, the recommended is you can have 50 deceased, 50 normal. At least if it is not possible, you can have 60-40 ratio as well. 60 can be normal and 40 can be deceased. Okay, now I do not have such data. What to do is the another problem. Yes, you should be able to generate what is called synthetic data. What is synthetic? As the name indicates, synthetic means man-made, artificial. So whenever you do not have sufficient data, you can generate synthetic data. A lot of applications are available to generate synthetic data. Number one. Number two, whenever you have data where only 20 patients are affected by cancer and 80 patients are normal data patients, then you need to do what is called a class balancing. There are a lot of techniques, lot of methods available to do class balancing. Lot of methods available to solve the problem of class imbalance. One common approach people do is called SMOTE, S-M-O-T-E, synthetic minority oversampling technique. This is a recommended approach for balancing the data, or you can say, how do I convert a class imbalanced data to a balanced data? You can use SMOTE. SMOTE is one technique. There are other techniques that are available. You can use it, but this is one recommended technique. Okay. Now I have pre-processed my data. I have, for example, let us say I have data of 100 patients. 60 patients are normal. 40 patients are having cancer. Okay. Now, whenever you do training and testing, you need to split the data set into two parts. Okay. It is called the training set and the testing set. When you split the data set, keep one thing in mind. The training data and the testing data needs to be mutually exclusive. You cannot use the same data for training and later use the same data for testing. No, not a correct option. Then you may end up with getting an accuracy close to 100, but that is not an actual accuracy that you have to get. So please note that the training data and the testing data needs to be mutually exclusive. Then you can train the data set. Then after that, you need to look at the test data set. Here, when you train the data set using 60-40 is the recommended approach. Okay. So where 60% of the data can be used for training and the rest 40% can be used for testing. Okay. Now here also there is another major problem. You can try out manually for a small set of data and see. Okay. You take about a data set with about 10 patients. Okay. Where 6 patients are normal and 4 patients are having cancer. Out of that, I want to use any 6 for training and any 4 for testing. You take the first sample, third sample, fifth sample data and do training. Use the rest for testing. You will get a different result. When you take 1, 2, 4, 5 randomly and do training and then use the remaining for testing, you may end up in a different result. Now, what is the major challenge here? The major challenge here is to decide which data to use for training and which data to use for testing. So in order to solve this problem, researchers have come up with a technique called CV, cross validation. It is called K-fold. You can even call N-fold. K-fold or N-fold cross validation. What is the value of K? That is another question. Normally, traditionally, typically, the value of K can be set to 10. Okay, it is called 10-fold cross validation. That is what people do normally. So what is K or N? You can divide the set into K smaller sets. If I am using a 10-fold cross validation for a data with 100 samples, what it will do is in the first iteration, it will use the 90 samples for training and the 10 for testing. The next, it will rotate. It will keep on rotating for 10 times and it will take what is called the average. So this is what is called K-fold cross validation. Next, parameter. What is a parameter? A parameter is a property of the training data learned by training a machine learning model or a classifier. What is a parameter? A parameter is basically used for implementing what are called optimization algorithms. What are some examples of parameters? A weight in an artificial neural network is a parameter. The support vectors in an SVM is a parameter. The coefficients in your linear regression or a logistic regression is a parameter. So what is our objective? Our objective is to fine tune, tweak the parameters to get better results. These two things are some of the major problems that you always find in machine learning. The first problem is called overfitting. Overfitting occurs when your model learns the training data very well and incorporates details and noise specific to your data set. You can tell a model is overfitted when it performs great on your training or validation set, but poorly performs on the test data. See, whenever you give your own data set and you train and test it, it will perform very, very well. If I supply a real world data, it will perform very poorly. Then that is called overfitting because it has learned what you taught. But when I come up with a new problem, it is not able to solve, which means your machine has not gained actual knowledge. Then what is underfitting? This is the counterpart of overfitting. This normally happens when a machine learning model is not complex enough to accurately capture relationships between the features and the target variables. Both are problem. Okay. So you should solve both overfitting and underfitting. Then the next thing is called bias. This most of the times you have heard, right? What is bias? In computer, bias is the difference between the average prediction and the correct value which we are trying to predict. In literal terms, you might have heard of the term called bias in many places. See, whenever you go for writing your public examination, they supply what is called a dummy number. Why? Because we want to remove bias. Bias is something where you try to lean towards something which you are not supposed to do. Okay, so that is called a bias. So humans normally tend to get this bias. Okay, since you may like somebody, you are biased. So in order to remove all these things, we give what is called, a dummy number when you write your public examination. We do not want the examiner to be biased, right? Okay. These humans are already tend to be biased. That is the human nature. Otherwise, what is a bias? In terms of a computer nowadays, whenever you talk of AI, artificial intelligence, there also we have talked of what is called bias. So in artificial intelligence, where do you find the bias? So interestingly, it says whenever you probably call somebody in the customer care, there is an automated message, voice message that comes, right? So that voice message normally typically will be a female voice. So now we say, you know, the artificial intelligence is also going to be biased, right? So this has to be definitely removed. So bias is the difference between the average prediction of your model and the correct value. So we don't want this bias. Next, variance. Variance also is nothing but talks of the spread. The model with a high variance pays a lot of attention to the training data, which means it does not generalize on the data. So you want to probably address all of these things when you probably design a model. Okay, so we will see how we can do it. Now, when you talk of the types of machine learning algorithms, yeah, 1 minute. So is the screen visible, madam? Hope it is visible, right? Okay. So types of machine learning algorithms. The first is called supervised learning. The second is called unsupervised, otherwise called descriptive learning. The third is called semi-supervised learning. And the last one is called reinforcement learning. So what is supervised learning? Supervised learning is nothing but the machine has what is called a supervisor or a teacher who gives the machine all the answers. For example, whether it is an apple in the picture or an orange. The teacher who does it has already divided the data into oranges and apples, and the machines use these examples to learn one by one. This is called supervised learning. One typical example for supervised learning is what you do or see in the classroom that you learn, right? So there is a syllabus. So the faculty comes to your class every day, delivers the lecture, right? And you learn, you take notes. That is called supervised learning. Learning under the supervision of a teacher. So very simple example, you have a set of training data. So you have a set of labels as well. Labels are available. So when an algorithm learns from example data and associated target responses in order to do some kind of prediction later, then that falls under the category of what is called supervised learning. Same thing holds good. Okay, supervised. So given a picture of male, female, predict his age, predict his high school. So supervised learning. So for example, predicting whether a tumor is malignant or benign is a classification problem. Classifying an email is spam or not is again a classification problem. Face recognition is again a classification problem. These are all supervised learning methods. There are a lot of supervised learning algorithms available like KNN, Navy Base, decision tree, logistic regression, SVM. These are some very well-known supervised learning algorithms that are available that you can use. Then next one, what is unsupervised learning? Unsupervised learning is learning without the supervision of a teacher. I will give you a very simple example. If you take your syllabus, there may be some topics which you might have learned in your previous semester or during your school days. So the faculty may simply come and tell this is the topic. This is going to be a self-study topic. You learn on your own. Later, I will come and give you a test in the topic. That is typically what is called unsupervised learning. Unsupervised learning is typically learning in the absence of the teacher. Okay. So there is no label available. The feature label, the last column is not available in unsupervised learning. Okay. One unsupervised learning model is called clustering, where you are basically going to divide the objects based on unknown features. The machine will choose the best way. Okay. So there are no labels. You need to discover interesting structures from the given data. In unsupervised learning, there is no instructor or teacher. The algorithm must learn to make sense of the data without the guide. Okay, this is what is called unsupervised learning, that is learning without the teacher. Clustering is one unsupervised learning method, detecting potential useful clusters of input examples. For example, a taxi agent might gradually develop a concept of good traffic days and bad traffic days without ever being given labeled examples of each by a teacher. I told you one another typical example very clearly, dimensionality reduction. Dimensionality reduction is another unsupervised learning technique. Then association rule learning is another unsupervised learning technique. Look for patterns in the orders stream. That is what I told you. Remember, customers who bought this item also bought. You get a lot of recommendations in Amazon. That is nothing but unsupervised learning, association rule learning. So the basic typical difference between supervised and unsupervised method. Supervised uses labeled data, unsupervised no labels. You get direct feedback in the supervised because there is a teacher available, no feedback in unsupervised. You will be able to predict the outcome in supervised, whereas you only need to find the hidden structure in the data using an unsupervised method. So these are some of the typical differences between a supervised technique and an unsupervised technique. So whenever you want to solve any kind of a real world problem, it is always better to go with a supervised method. Whenever you get any kind of unlabeled data from a computer, then obviously you need to go for what is called an unsupervised learning technique. Then there is something called a semi-supervised. Semi-supervised, as the term indicates, lies somewhere between supervised and unsupervised. So in the case of a semi-supervised learning, there are some samples that are labeled, some are not labeled. Then I call this to be what is called a semi-supervised learning. So it basically makes use of a large amount of unlabeled data for training, and then it will use a small amount of labeled data for testing. This is what is called semi-supervised learning. So this is semi-supervised learning, like speech recognition, internet content classification. Lot of bioinformatics applications come under the category of what is called semi-supervised learning. Then there is a fourth type of learning, which is a very interesting. It is called reinforcement learning. This accompanies an example with positive or negative feedback according to the solution the algorithm proposes. It is otherwise called learning by trial and error method. So how to act or behave when given occasional rewards or punishment signals. This is called reinforcement learning. Okay, so you have 7 steps in machine learning. You need to definitely remember this. It is called the machine learning life cycle. You have gathering data, prepare the data, we call it as data wrangling. Then you analyze the data, you train the model, you test the model, and then you probably deploy it. Yeah, take a very simple example of classification of oranges and apples. With this, I will explain the machine learning life cycle to you. Okay. Step one is called gathering data. What is gathering data? Data collection. First real step of machine learning is gathering data. Quality and quantity both play a typical role in gathering data. For example, if the color is red, the shape is round conical, I probably classify it as an apple. If the color is an orange and if it is round in shape, I then typically classify it as an orange fruit. So for collecting data on color, you can use a spectrometer. For the shape data, you may take a lot of pictures and you can create it as 2D figures. Okay, so this is step number one, gathering data, data collection, building the data set is very, very important. Step two, data preparation. Whatever data that you have collected in step one cannot be used as such. It is called raw data. So what do I do? For example, I load the data into my machine. The very first thing I would like to do is called randomization. Randomize the given data. This will definitely improve the model. It is like shuffling, okay? Then next, you try to build on visualizations of your data. Okay, more data points about Apple than Orange, the model we train will be biased. So please understand. Then split the data into two parts. First, used in training our model will be the majority of the data set. I call it as the trained data, 60%, no problem. Second part will be used for evaluating our model. Let us call it as the test data. Don't use the same data for training and testing. This is step number 2, data preparation. Step number 3, choose the right model. Okay, categorize the problem in terms of input, in terms of output. Look at the constraints of your system and then go for searching what are the various algorithms that are available to solve your given problem. The next very important step is to do the training on the model. Then you go for prediction and then you go for testing the model wherever you are. You need to update the W and B. W stands for weight, B stands for bias. So use our data to incrementally improve the model's ability. Okay, the weight and bias, y equals m into x plus b. M is called the slope, x is the input, b is the y-intercept, and y is going to be the output. So we always would like to work on the W and B, the weight and the bias. Then you go for evaluation of the approach using a lot of parameters, which I am going to tell you quickly what are the various parameters you can use for evaluating your model. Then you go for parameter tuning, further improvement to training. Many times we run through the training data set, right? Then you do what is called parameter tuning. And the last step is called prediction or inference. So whenever the color is red and the shape is going to be round and conical, you give it to a model, then the model will going to be predict it is going to be an apple. This is called prediction, otherwise called inference, right? So this is the last part of my presentation. The last part of my presentation typically focuses on the various evaluation metrics in machine learning. Okay, so we will go through the various evaluation metrics so that it will be useful for you to understand which evaluation metric where to use. Okay, so that is the basic objective. So this is the last part of the presentation. So just hold on. Okay. So what are evaluation metrics? Evaluation metrics will explain the performance of the model. So the evaluation metrics are basically divided into some categories. Whenever you talk of a predictive model, you have two varieties. One is called the classification. The other one is called the regression. Now, whenever you talk of classification, you need to talk in terms of accuracy, precision, recall, specificity, F1 score, AUC, ROC, area under the curve, region or receiver operating characteristic. Whenever you talk of regression kind of problems, you talk of all the different varieties of error, MAE, MSC, RMSC, mean absolute error, mean squared error, root mean squared error, and so on. So we will go through one by one, okay? Whenever you want to work on any of these things, the very first thing you need is what is called a confusion matrix in a classification problem. A confusion matrix is an n cross n matrix. To put in very simple terms, I call it to be a 2 by 2 matrix, where n stands for the number of classes being predicted. So if it is a binary classification problem, it will obviously be a 2 cross 2 matrix, 2 rows, 2 columns. So the table describes the performance of a model by grouping the prediction into 4 different categories. So the first is called TP, true positive. We correctly predicted you do not have cancer or you have cancer, whatever. A cancer patient is predicted to have cancer. Yes, means it is called true positive. The next is called true negative. As the term indicates, we are able to correctly predict that the person does not have cancer. You don't have cancer, you are correctly predicted as you do not have cancer, then that is called true negative. The next is called false positive, otherwise called type 1 error. False positive says we incorrectly predicted that you have cancer. This is very, very dangerous, right? Actually, you do not have cancer, but your system predicts and says you have cancer. Very dangerous. The next is called false negative, otherwise called type 2 error. We incorrectly predicted you don't have cancer. So this is also another problem, right? So we incorrectly predicted you don't have cancer, but you have the disease, but your system says you do not have. This is also again a problem. Both are issues. So we want to reduce the type 1 error and the type 2 error for a given problem. This is the table, okay? TP stands for true positive, then FN stands for false negative, FP stands for false positive, TN stands for true negative. So negative actual, negative predicted, called true negative. Remember this, okay? These are some formulas, okay, to calculate the various metrics. I will tell you the first metric everybody will obviously look at is called the accuracy. So accuracy is the ratio of the number of correct predictions, that is TP plus TN, divided by total number of predictions, all put together, okay? So the value of accuracy normally will lie in the range 0 to 1, okay? So better the higher the accuracy, better the model, okay? Which means the TP, true positive, and TN, true negative, needs to be higher. Always remember, whenever your data set is said to be imbalanced, accuracy is not a useful metric. That is what I told earlier itself. Whenever you work with imbalanced data, always make your data to be balanced before computing the accuracy, because obviously the data sets are going to have the uneven distribution of classes. Accuracy is the first one. Okay. So you can know, consider the following values of the confusion matrix, how to compute the accuracy. So 300 plus 150 divided by the total, right? 500, right? So what you get is nothing but 80%. Then next one is called precision. What is precision? Precision is equal to TP by TP plus FP. It is the number of correct positive results, that is TP, divided by number of positive results predicted by the classifier. So precision is a measure that will tell you what proportion of patients that we diagnosed as having cancer actually have cancer. Very, very important. This is called precision. So predicted positives and the people actually having a cancer, you should know. Then next is called recall. Recall is also called sensitivity. The formula for recall is TP, true positive, divided by TP plus FN. So true positive rate, TPR, we call, or recall. Recall is a measure that tells us what proportion of patients that actually had cancer was diagnosed as having cancer. So that is the TPR we call true positive rate. So precision is useful when you want to reduce the number of FP. Consider a system that predicts whether the email received is spam or not. Taking spam as a positive class, we do not want our system to predict non-spam emails as spam. So our key objective is to reduce the number of false positives. In that case, you can use precision. Okay, you can compute. Recall is useful whenever you want to minimize the number of FN, otherwise called false negative. Sorry, somewhere we lost it. No problem. Recall is also called sensitivity, how sensitive your result is. Okay, fine. So recall gives us information about a classifier's performance with respect to false negatives. How many did we miss? But precision gives us information about the performance. How much did we catch? So focus more on minimizing FN. If you want to focus on minimizing FP, you use precision. So that is left to you. Okay. Specificity is equal to Tn divided by Tn plus Fp. These are all some standard formulas. Okay. F1 score is a metric that combines precision and recall. The formula is simple. It is 2 into precision into recall divided by precision plus recall. So the value always lies in the range 0 to 1. More the value, better the F1 score. Next is ROC. ROC is otherwise called the receiver operating characteristic curve. This curve is normally drawn with the FPR, false positive rate, on the x-axis and TPR, the true positive rate, on the y-axis. Then you plot it, you will get a curve. So in the graph that you see, when you see a straight line, I call it to be an ideal curve, which most of the time you will not get. Okay. So when it leans towards the y-axis, it is always a good one. It is excellent. So AUC basically stands for area under the ROC curve. This is an aggregate measure of performance across all possible classification thresholds. Okay. More examples are there. I will share. You can work out and see. I will share this slide. These are all you need to work out. Okay. Then next, my focus is on regression. Regression, some of the evaluation metrics that are available. The first metric is called MAE. MAE stands for mean absolute error. So it is nothing but 1 by n sigma I equal to 1 to n yi minus yi cap. Yi is the actual expected output and yi cap is the predicted output. So what is mean absolute error? Mean absolute error is the difference between the actual expected output and the model's prediction. So this is not a much popular method compared to other metrics. This is a very simple metric. So this is not a most common or whatever popular method people are using nowadays. So next one is people are using is called MSE, otherwise called a mean squared error. This formula slightly differs from the first formula where we are squaring the difference. The error term is squared so that it becomes more sensitive to outliers. So you can compute with some example. The next one is called RMSE, root mean square error. So MSE squares the terms. Here we take the square root of the MSE. The formula is not much different except that there is a square root put. This is called RMSE, root mean squared error. You can compute using the formula. Then you have the R square error. R squared error is calculated by dividing the sum of squares of the residuals from the regression model by the total number of sum of squares of the errors from the average model. Then you subtract it from 1 minus SS RES by SS total. So this is there. These are the various what you can call is the evaluation metrics that are available that you can use to do any kind of classification or prediction. Yeah. So this basically gives you an overall understanding of what we call it as, the basic introduction to machine learning, artificial intelligence, and what are the various applications you can do. Like, for example, you can do cancer classification, handwriting recognition, and spam classification as spam or not spam, and so on. So these are some of the applications of AI and ML that are available, and you can probably make use of all of these metrics to probably use it for your applications. So this concludes the talk of an overview of the AI and ML. So if you have any of the queries, you can pass on your questions to your faculty, and then I will probably send you the reply. And if you need any help also in any kind of projects or anything later, so I will be able to probably help you and guide you in that as well. So this concludes my talk on AI and ML and its applications. So thank you. Madam, any other thing is there? You can.
Sir, it was so nice of you, sir. Thank you so much, sir. Sir, and I would like to communicate with Dr. Chandrasekhar, sir. He's a CSI member, I suppose, secretary, sir. And
Okay.
he's on the, yes, sir. He's actually right from the start, he has joined us, sir.
Okay,
so
okay.
now over to Chandrasekhar, sir, please, sir. Chandrasekhar, sir.
1 minute, I will just change the settings, madam. 1 minute.
Yes, sir.
Yeah. So I have just enabled the mic, madam.
Yes, sir. So right from the start, he's there, sir.
Oh, very good, madam.
Dear yes, sir. And dear participants, we are very happy to say that we are very thankful to Computer Society of India for they have funded us with the amount we have required. So we are expressing a sincere gratitude to Computer Society of India for their contribution, which is very crucial at this moment for the success of this webinar, which has been initiated as the foundation lecture series from CSI Celebration, and I suppose this will greatly significantly impact and title whatever resources Dr. Arun Kumar sir has taken. I think this will create a significant impact in our technical path. And, sir, Chandrasekhar sir is online, sir.
Yeah, I see sir is online.
Yes, sir.
Am I audible, madam?
Yes, sir. Yes, sir.
Am I audible?
Yes, sir. Yes, sir. Yes, sir.
Oh, thank you. Thank you, madam. This is Chandra Dasaka. I'm Head Academic and Industry Council, Computer Society of India. Thank you very much for inviting me to join the program, madam. Dr. Arun Kumar sir, thank you very much for the presentation on machine learning and artificial intelligence. Your expertise and passion for the subject shown through making complex concepts accessible to all. The examples you have shared were highly insightful and appreciated. They're very good, sir. Your ability to engage the audience and address us is very impressive. We are grateful for the knowledge and inspiration you have shared with us today. Your contribution to the webinar is invaluable. Madam Anna, this is wonderful program we had. As I told you, we will post this video on CSA website.
Sure, sir. I will just share the video, sir. After uploading on YouTube, I will share the link, sir. Yes, sir.
Okay. Yeah, otherwise we have Computer Society of India Academic and Industry Council has a separate YouTube channel. I will host in that also.
Sure, sir. Sure, sir.
Okay. Sure, sir. Thank you so
Okay,
much, sir.
Ah,
Thank you,
wonderful,
sir.
Amma.
Thank you, sir.
Thank you.
Thank you so much, sir.
Thank you, madam. Thank you.
Right.
Amongst your busy schedule, you have joined us, sir.